All right, so I'm going to be making an intake tube for my 350Z, and I thought I'd show you guys kind of the process I use. So most of the time, I'm always starting a project with a 3D scan nowadays. I have two 3D scanners at my disposal, so I definitely utilize them as much as possible. Once I have that scan data ready and cleaned up, I'll move over to Fusion 360, go to Mesh, wait for it to import, and then we can start basically removing some of the mesh data just to speed up the process. There's going to be a lot of triangles on here that I do not need. Obviously, it's very high resolution. Could be higher, but it's still pretty high, and it's going to slow the workflow down a bit. So I'm going to actually go ahead and create a copy of this. And then on that copy, I'm going to reduce the mesh and then get rid of this whole factory intake. So I always go center, move to ground. Bodies, I think it makes a duplicate, but I always go ahead and just make my own duplicate first. So just copy paste, hide the first one, hit OK, and then we're going to go direct edit, select, and there's probably a million different ways to go about what I'm doing for this entire process, but again, this is just kind of my workflow. Whether it's right or wrong, it does work for me. So I'm going to highlight everything I want to delete. All right, I got the space cleared out pretty good, but again, I can actually go ahead and turn on the other body once I finish direct editing this, just to use the factory intake tube as kind of a reference so that I'm kind of following the same path. I'm actually going to go ahead and hit finish direct editing right now, and then we're going to reduce it. 25, yeah, that's fine. It doesn't look like it changed a whole lot, but it definitely did. It reduced the triangle face count by quite a bit, so it should run a lot better. I have a pretty powerful computer, and even with it, it still manages to bog down quite a bit. I'm going to bring back my original one, and then we're going to create a mesh section on this one. And what we're looking to do is manipulate it, kind of move it around as close to the throttle body and mass airflow sensor as possible to kind of retain the factory start and stop points and get those kind of as close as possible. So go ahead and manipulate around, slide it over, and then I'm looking to basically cut a cross section of this tube as perpendicular as possible. So, I'm going to use these lines as a reference and hopefully get it matched up all the way around the tube as close as possible. And this does take quite a bit of just playing around, tweaking it back and forth to get it as straight as possible. All right, that looks pretty good. Go ahead, hit OK. You can see there's an orange line kind of going through the whole mesh. I'm going to go ahead and do the same thing down over here where I want the intake tube to end. So I'm going to shoot for right here, right before the air box. And it looks pretty straight, pretty perpendicular to this section of tube here. So I'm going to go ahead and hit OK. I'm going to go back to hiding that sketch, drawing, and then there we go. We can see those orange sketches, one for the mass airflow sensor, one for the throttle body. And now you can actually go in and manipulate. This one is no good, so we can go back actually in and manipulate this. Go to edit sketch, and then now you are on a sketch plane for this right here. So if we go over here and go to fit curves to mesh section and then hit circle, you'll actually find a really close circle right there. And then we can actually check and see what size that is, even though it's not going to be exactly accurate of what we need. It's saying the outside diameter of that tube at that spot was about 83 millimeters. That is fine. And then we are going to do the same thing on the end point. Create. And there we go. So that is a pretty good start and stop point. And then we'll basically go in and fill in the gaps there. As it is right now, because we have these two circular profiles, I can actually go straight over to surface and loft between these two circles. But as you can see, it's going to basically intersect, and obviously wouldn't be ideal for airflow. So we need to create a sketch line between the two before that. So I've actually gone ahead and separately measured the inner diameter of the throttle body and the mass airflow sensor, so I can actually get a really accurate dimensions. But what I'm going to do is actually use this as a reference for the starting point, and then drag it out, and then we can go ahead and dimension that. So the ID is actually 75 millimeters. Go ahead and finish that sketch. Do the same thing over here. This one is 72. And we really want to make sure we're very accurate on the mass airflow sensor. You need to be within a millimeter, maybe two at the most. Anything more than that will significantly impact your readings on your mass airflow sensor, which is going to cause a check engine light. So it needs to be accurate unless you have a tuner or you are able to actually compensate for the additional or lessened airflow. So make sure it's close on both sides, ideally, because you really want to have accurate measured airflow. All right, so it looks like we're all squared away. We have the two correct diameter faces. They are going to be the start and stop point for the intake tube. So I'm going to go ahead and click create a sketch. I'm going to choose this kind of top-down plane, and I'm going to choose fit point spline. And then I have a 3D sketch selected because I need to basically draw a line between this and this face right here to use as a center point reference between the two circular faces. So again, it's a straight line, but it's ideal to kind of connect those connect the spline right away. Then we can select it and insert spline fit point. So I'm going to do one like right here, and then another one right there, and then we can actually go in and manipulate these by right clicking and going to move copy, and then kind of drag them around until, oh, I did get another one right there. Let's go ahead and delete that, and then kind of manipulate it until we get something that fits within this profile. I'm kind of shooting for the center between the intake manifold and then the portion of the firewall. I guess not really the firewall, but it's whatever this trim piece is. And you could throw on the factory intake mesh to kind of use as a reference. I could definitely shoot for, center line of that. And we know we should be in a pretty happy, good spot. And then it will take a little bit of manipulation to kind of get the heights right on everything too. So this looks too tall. Bring that down. I want to bring this one up a little bit. Pretty straight line on that right plane. Top down, it looks pretty nice and smooth. I'm going to go hit OK. Bring back the mesh, and then I can try and loft again just to see how it looks. See how close we are to what I'm hoping for. Okay, so again, straight line until we go right here, hit plus, and then we want center line. And voila, we got a tube. We got an intake tube. So that definitely gets us in the ballpark of what we're going for. From here, there's just a lot of cleanup and detail work. The nice thing about this surface, you can actually just click it and then go down to thicken, and then we can actually thicken it to whatever wall thickness we would like. So for 3D printing, I'm actually going to just do a 2 wall with a 0.4 millimeter nozzle. So I'm actually going to go slightly below that. So 0.79, just to make sure there's a good infill, solid wall, no gap between. A little bit of overlap there, and we have a solid tube, and this can be 3D printed right away. The outer diameter is going to be a little thin right here, but it should work with a silicone coupler or something like that. Same thing on this side. All right, so once I got that saved, looking like an intake tube, I'm going to actually import the air filter I want to use. I already have this laying around, and I figured it would be nice to incorporate it. I'm just going to put it in a arbitrary spot that looks like it would be good. And I'm actually going to go back and redesign this to, let's get this closer to the factory airbox. So I want this sticking down, make sure it's not going to hit the hood or anything. Maybe over here more. Looks like that would probably work pretty good. Maybe a little bit more over here. Down a little bit. All right. Now that I'm pretty happy with that, I'm actually going to go back and in and basically start from scratch, redo this entire center line and these 2 points. I do need this diameter right here towards between here and somewhere around here. I'll create basically a face to constrain the diameter of the tube right here, so I can get the mass airflow sensor properly constrained and the right diameter. But I do want to build in a velocity stack, whether it's a separate piece or it is all in one tube. But as you can see, the air filter has about a 6-inch opening that I want to put a large radius velocity stack basically on the inside of. And then I have to figure out a way to basically connect between the two. But one thing also I wanted to note is you can actually, let's get rid of these, delete it, and we'll bring back my sketches. And then we can actually go in and further refine or define how large the diameter of the tube is. So as we know, this is 75 millimeters and this is about 72 millimeters right there. But say we want to go a little bit larger throughout the center portion, I can go in and actually do a plane along path and select this as the path, and then say we want to make one right there. Okay, repeat, sure, and then we want to do one right here to kind of constrain the mass airflow sensor. So I go ahead and hit OK, and then now we can use these planes as to create further dimensions and kind of use that to draw on to enlarge the tube. So if we take this and it gives us our center section, click that with our circle, and then we can open this up to, let's say, like, sure, that works, 90, let's go 95. So obviously it's quite a bit larger. We'll see where we're going with this in a second. Let's hide that, finish the sketch, and we'll move on to the next one. Same thing, and I will define this as, let's go 90, finish sketch, and then the last one, choose it, and then same thing. Oops, there we go. And again, this needs to be give or take 72 millimeters. All right, so we got some extra circular profiles here. Kind of looks a little weird, but if we go back and let's go to finish sketch first, loft, and then we can take these profiles one to the next, and then we got a significantly different looking tube, and we can actually go ahead and choose that center line again. It'll kind of change the profile of the tube, and it'll keep it a little bit more uniform and smoother. So the nice thing about this, it's all parametric, so we can actually go back in and modify this center line, move it left or right, or change the diameter of these circles to enlarge the tube or shrink it down in areas if we need to. But it's pretty significant difference actually just doing this. And I recommend this because we're going to need some tangency for this line here. Otherwise, it's going to be hard to get the coupler kind of on this where it's increasing in diameter. So sometimes I'll actually go back in and create an additional plane, probably an inch and a half away from where the throttle body's at, and then same thing with the mass airflow sensor, just to make sure the coupler will go on straight and not crooked. But let's go ahead and select that. As you can see, that straightens it up pretty good. There's a little bit, it does grow, but this might not cause any problems for what we're trying to do. But if we bring this back, and we can hide some of the sketches, that is kind of what we're looking at. So again, thicken it, and there we go. Sorry, I'm moving around kind of weird, kind of crazy, but that's a general idea of what I do to create these intakes. It will take a lot of tweaking and playing around to kind of get it mated up to this air filter I plan on using. But anyways, that is the general idea and kind of workflow I use to create these parts. So if you made it this far in the video, thank you so much for watching. If you enjoyed it or you found it useful, please hit that like and subscribe button. It would mean a lot. And I will see you guys in the next one. Stay tuned for part 2. I'm going to actually be dividing this up into multiple parts, 3D printing it, and then test fitting it on my 350Z. So stay tuned.